name is Jodie Liu, and I'm a junior at Diamond Bar High School.
Hi everyone, I'm Jordan Hong, and I'm a senior at Diamond Bar High School.
Hello everyone, my name is Augustus Rodriguez. I'm a sophomore that goes to Walnut High School.
And we're here on behalf of the Walnut Solar Car team. So what is Walnut Solar Car? Our team was established in 2005, centered on the importance of a hands-on approach to engineering. So every year we meet through the year-long weekends, and we create roadworthy solar cars in order to race at the Solar Car Challenge in Texas every summer. This year we're comprised of 17 Walnut Valley Unified School District students, and each one of us takes an active participation in learning the different aspects of the car in order to make it functional and ready for the race. So our mission and purpose. As a student-run group, we really try to motivate one another to learn not only one area of engineering, but also to challenge the others. So for example, the students are separated into mechanical and electrical engineering, but they're really encouraged to, cross over to the other side and really take an in-depth understanding of the entire car, not just one part. So why solar car? So solar energy is considered to be the most renewable source of energy, and we want to also dip our feet into the current advancement in the development of electric-powered vehicles. We want to be a part of the action that advocates green energy to better the environment. So this is our solar car from last year, TARS, named after the intelligence robot in Interstellar. And we took it to the race last year, and we plan on bringing it back this year, only with newer improvements. So the first improvement is that we changed our lead-acid batteries to lithium-ion batteries. So we learned from what we got from last year, so we analyzed our experience and learned what we needed to change in order to create a more efficient car. And so in addition to the lithium-ion battery pack, we also installed some new higher efficiency solar panels, and also with that, solar cells. In addition, we, after scrutinizing the car, we realized that some of the components need to be changed, such as the mechanical aspects. So some of the things that we'll also be talking about today will be the difference in the aerodynamic frame, and also the cutting down of the weight and reducing the rolling resistance of the car. So to start off, the lithium-ion battery pack. Before we used lead-acid batteries, and those produced about 2 kilowatt-hours, or in turn 2,000 watts. With the lithium-ion battery pack, we are able to have 5,000 watts, or 5 kilowatt-hours, which is significantly more power, and also puts us into the advanced division at the Solar Car Challenge. So the makeup of the battery pack, as you can see here, is that we have 10 individual cylinder batteries put in together to one block, and then 15 blocks wired together to make our volt system. So each one of those individual cylinders is roughly around 3.4 volts and also produces 10 amp hours. So in order to create our 48 volt system seen right here, each block is wired in parallel, which means we have 10 cylindrical batteries stacked together in parallel. And the purpose of our wiring in parallel is so that the amp hours are added together. So 10 amp hours per battery would mean 100 amp hours per block. And then we take each of those blocks and wire the 15 of them in series. And wiring in series increases the voltage, but the amperage stays the same. So 15 blocks times 3.4 volts about each gives us close to our 48 volt system that we use to power the car. And now Gus will talk about our installation of the new solar panels.
Thank you, Jodie. So, high efficiency solar cells. So this year's race, we're competing in the advanced division, and the minimum efficiency is about 18%. Our panels currently right now are 18.5%. Now, our old panels that we had on our old car, Horus, the panels would give an efficiency of about 17.5 to 17%. And then the problem was that the panels were too huge on the car and it would cause drag. And now we asked ourselves, what can we do to minimize the drag on the car for better aerodynamics and also get better efficiency? So then what we did is we got panels that are corrugated and has glass material over it to protect the cells. and the efficiency is now 18.5. Now each panel produces about 100 watts. The total array, as you see on the picture, all the panels on the car give about 1,250 watts. Now, to figure out how many watts each panel gives, we multiply our volts times our amperage, amps. So that's about 17.8 for the volts times 5.62 our amps, which equals 100 watts. Now, current, which is the amps, transfers through the power trackers, which is an inverter, to our battery packs. Now, the amps that flow through the entire car is about 25.8 amps, and our battery pack, which is a 48 volt system. Now the total power, to find the total power of all the watts, what we do is count all the panels on our car, which is 12.5. Then we multiply that with each panel, like each watts. So that's 100 watts for each panel. So that's 12.5 times 100, which is 1,250 watts. And to explain the process how our watts transfers to our battery pack, our lithium-ion battery pack, our solar panels sense the watts into current, through our power trackers. Now our power trackers is an inverter. Some people like to call it a transformer. Our power tracker is a DC-DC. What it does is that, our battery pack runs on a 48 volt system. Sometimes our solar panels give off 75 volts. To control that, our power trackers minimize it, compact it, and then sends it through our BMS system. BMS stands for Battery Management System. That goes through our BMS system, then goes to our lithium-ion battery packs. Now I'll leave Jodie will talk to you about aerodynamics.
Okay, so there are three main components to building an efficient solar vehicle. The first one I'm going to talk about is aerodynamics. And the way we accomplished excellent aerodynamics is we used a low profile for our body, and we also made it narrow. This allowed us to also have a small frontal area, and a small frontal area will allow us to cut through the air much nicer than, say, a truck. We also limited the number of protrusions sticking out of our car. Examples of this were we attached our side view mirrors in the inside of the canopy, and we installed our shock system inside the car. This was inspired by Formula One race cars, and it's called the cantilever system. The second component to having an energy efficient car is the weight. We use a lightweight aluminum frame for a body instead of steel. We also decided to use shrink wrap, which is a plastic-like material that is stretched over the car and heated. It forms a skin-like layer over the body. We decided to use this because the alternatives, steel plating or aluminum plating, were much too heavy, and we didn't want them to cause too much drag. Now, the final thing to reduce the weight of our car was we used lithium-ion batteries as opposed to the lead-acid batteries, as mentioned before. Now, the final component to building an energy-efficient car would be the rolling resistance. We use thin, high-pressure bicycle tires to reduce the contact area with the ground. And the reduced contact area reduced the amount of friction with the ground, and thus allowed us to be more efficient with our power. And along with the thin tires, we also decided to use oil instead of grease for our bearings. And what oil does, it keeps the bearings lubricated within the wheel, but also isn't as thick and restrictive as grease is.
So in the end, our true test is to take each of the different components and put them together to make this functional solar car. Together we try to learn from our mistakes, but also to use that prior knowledge that we have in STEM categories to not only fix what we have to fix now, but also anticipate the problems that we might have when we're at the race or anything in the future that could go wrong. So now we have a video of our experience last year at the race, where we won second place in the advanced division. Sorry.
What a beautiful car. Car number 23. You had 5, 4, 3, 2, 1. Good luck, Walnut. That's okay. Thank you very much. Aye. Our next car is also from Walnut in California. This is their new electric solar-powered vehicle. 5, 4, 3, 2, 1. Good luck, Walnut. Have a great day.
So just in conclusion, as you saw in the video, we also, for the first time last year, entered a completely electric-powered vehicle into the race as well. But this year, we're just going to take the improved version of our old car, Tar. And I just want to stress that as a team, we really push one another to have an in-depth understanding of everything that is involved in the car. Such the number of different aspects that come together ends up having a huge impact on what we learn and how we therefore have the experience at the race. And thank you for listening.
Thank you very much. Before we get into our stars, any questions from the audience about the solar car? Sir,
Are you guys limited to 48 volts? Is that a limit to the competition?
Yeah, so no, there's also, we can also structure it into a 96-volt system. However, for reasons of safety, we don't want if something did go wrong and we had a 96-volt system, the reaction of the lithium-ion batteries would just be really fast and it would not be safe because they would just catch on fire. And we don't want to cause harm to our car anyway that's permanent. And so for that reason, the 48-volt system is already efficient enough to make our car run smoothly.
I'm just curious, first of all, this is a very good presentation, but according to your design, does the panel gather a lot of heat? So when the guy's driving in the car, how do you guys do the heat out?
As rules of the race, we have kind of a ventilation system. We have fans installed throughout the car. We have a driver's fan and also a battery pack fan. However, it does get fairly hot in there under the Texas sun.
Okay, so you use the fan to do the heat out?
Yes.
Yes.
Okay, so most of the power might go to the fan then?
No, there's actually a separate, a little tiny auxiliary battery in the car that powers things such as the fans or the left and right turn signals. But the main drive system is connected to lithium-ion battery.
Okay, thank you.
Why do you guys, how'd you guys come up with the shrink wrap idea?
So previously, a while ago, before we had a new advisor, we used kind of a honeycomb structuring to protect the car, and that stuff is super bulky and it didn't really cut through the air as well. So we wanted something that could cover this frame that we already designed and make that more aerodynamic. And shrink wrap is both lightweight and it barely increases the surface area or anything. So that's why we went with shrink wrap.
So you said the race, how fast do these cars actually go?
Go ahead.
Our solar car reaches a top speed at around 40 miles an hour, and our electric car reached a top speed at around 50 miles an hour.
Are the performance factors merely velocity, or are they a combination of factors by which you're being judged? Acceleration, or duration?
Well, in the competition, there's this year it's a cross-country race. So it depends whoever gets there first, right? Am I correct?
Yes.
And then last year's competition was more on how many laps can you get. Yeah.
So basically the underlying things that you want to watch out for are definitely speed and your mileage, your endurance. But this year for cross-country race, there are checkpoints in which you see how fast you can get there. Yes.
You mentioned a lot of improvements that you guys made, including the batteries, the solar array, the tires, and things like that. Can you compare the top speed of before and after these improvements?
Yeah, so a while back when we used the steel frame and lead acid batteries, we had a top speed around maybe 35 miles per hour. And when competing with groups in the advanced division, they have kind of more advanced even motors. So their top speed is significantly more than 35, and so we took on the initiative to really amp up our abilities.
So is the car built from scratch, from parts where you go from, basically nothing but parts and you build everything from the frame? Where's your guys' starting point is what I'm asking?
Well, we do start from scratch. Last year, these were two completely new cars that we had decided to build. And we basically got the idea from our advisor, and we threw it around, oh, we should do this or this. And over time, we kind of evolved the car to perfect it. And we added individual parts along the way, such as steering wheel, electrical systems, but we started with the basic frame and went from there.
Okay. And the last question for me, because this is very interesting. You said you placed second last year. What innovations, what changes are you going to make to the car that you think is going to push you over the limit next year?
So one of the things that we really are proud of is our reliability. A lot of the cars that win first, they have installed a hub motor, which is, well, we have a DC motor, but they have a hub motor. And the problem with the hub motors is sometimes there are problems with the programming or there are problems with the installation of it. And so, for example, a couple years back, one of the teams that was a top runner, they completely trashed out their back suspension because of incorrect programming with their hub motor. And so, not only that, but also having a safe 48-volt system, having our car compact and able to kind of just stay functional throughout the race. And also, each of the team members understands what problems might come around, and so we are equipped at the race to fix anything that might surprise us.
All right, so let's go and see how many stars Miss Lou and her team from Walnut Solar Car get. All right, no particular order. Dr. Tiwari, creativity. Boom, we have a star.
Just basic clarification. You said solar is the most renewable of all energies. So just basic concepts, I think you might want to explain that. I mean, it's a given that this is a solar race, but if you say most renewable, what does that mean?
Oh, right,
It's not a
right.
question, it's just a comment.
Oh,
Yeah.
okay.
All right, exploration, Dr. Chu. We have a star. Dr. Wang, delivery. We have a star. Dr. Tony Chuk Fu, interaction. We said yes. We have a yes. And Dr. Zhao, logic. We have a 5-star winner.
I just wanted to make a quick comment. That was a great talk. You three all did a really, really good job. I really enjoyed your talk. The only suggestion as a logic judge is that you could slightly better use your data. You got a question from Dr. Chu that what was the speed before and after you make the improvement. For example, that's a very good opportunity for you to demonstrate your improvement by actual data. Yeah, I know you want to keep your talk for general audience, so not too much, but you know, by visualizing your data, you can be more convincing on the improvement you've made and the creativity that you have input in your system.
Thank you.
All right, congratulations to all.